In this section, we will be learning the hydrant system, its sizing, and the installation. This hydrant system we had already discussed earlier also in the previous parts as an introductory. And in this part, we will be considering its design, sizing, and the spacing of hydrants, etc. Type of hydrant systems. These are of two types. One is internal hydrant system and other is the external hydrant system. Internal hydrant systems are generally provided near the stairwell, and those are provided with the hydrant landing valve, and its outlet is a quick coupler. The sizing of internal hydrant and the riser means are explained in NBC Part 4, Table 24 also. Further, we will have a discussion on this in this part. In the Table 24, they have considered the internal hydrant with the different size of risers. That is about 100 mm dia riser and 150 mm dia risers. There are elaborate notes already provided, and the number of hydrants, whether it is one hydrant or two hydrant, and where it is to be provided, under what occupancies, those are also explained. Now, the external hydrants are generally provided when the plinth area exceeds more than 750 meters square. The external hydrants are placed along the periphery of the buildings, and the placing of these hydrants are according to the type of hazards, which is a light hazard. It must be placed not more than 60 meters spacing. For ordinary hazard, 45 meters, and the high hazard, 60 meters. This is the table 24 as we have referred in the previous slide. You will notice over here these are categorically explained, showing the size of mains, that is the risers, or the external ring main where the hydrants are to be provided with its size, and these are the type of building and its category and subcategory where these things will be applicable, and these are actually affected by the height of the building, and it has been clarified over here. You may notice over here the residential building A is having a category of lodging, rooming house, dormitories, one or two family private dwellings, apartment houses, shopping area not exceeding 500 meter square area, and the hotels. This is the Group A occupancy, which is the residential buildings, and this will be applicable within the limit of the site. Similarly, with the Group B, that is the educational building, it is to be provided 100 mm dia when the height is limited to 15 meters to 30 meters. And likewise, for the institutional buildings like hospital and the sanatoriums, custodial institutions and mental institutions, assembly buildings, these are also explained with respect to its height of the building. When we come to the business buildings, that is the Group E, this is be limited, the 100 mm dia will be limited to 15 meter to 30 meter high building. And the likewise Group G and industrial building are explained. With regard to with 150 mm dia, riser means those are to be provided with the twin outlet landing walls. The difference you will see that all these occupancies where this riser is provided will have a single outlet landing walls, and this will have a double or the twin outlet landing walls. This will be applicable where these conditions exist, like hotels. You see over here also the hotel is here, but between 15 to 30 meter height it can be provided with the 100 mm dia. But when the height of the hotel is more than 30 meter, it has to be provided with 150 mm. Similarly, these buildings, although these are discussed over here, but changing the hydrant size and the number of landing walls according to this height requirement. See, for the purpose of sizing the ring main, in particular along the peripheries of the buildings, it will explain the delivery pressures and the flow of the pump. What does it mean? It means that in the light hazard occupancy, if these are provided or if the hydrants are provided on the periphery of the different building by ring mains, the sizing of the pump's flow must be complied with this capacity, and the pressure of the pump must have this one, 5.6 kg per centimeter square, or say 5.6 bar, 7 bar, 7 bar. See, light hazard, when you say not exceeding 20, it means the total number of hydrants in the project, including the internal hydrants. When it is not exceeding 20 numbers, this is the pump's minimum pump flow is required, and its pressure should be 5.6 bar. Similarly, when it comes to exceeding 20 but not exceeding 55, this will apply with this pressure. In more than 55 and 200, this is applicable. And when it is exceeding more than 100, this will be applicable. Now there are the notes, the footnotes explaining this. The pump's delivery pressure will not exceed 7 bar if the higher floor of the risk is at a height exceeding 15 meters above the surrounding ground level. What we see here, this asterisk, this will be applicable over here. Similar way, what do we see over here? In the previous slide we discussed for the light hazard, and this is for the ordinary hazard. Ordinary hazard, same way, the number of hydrants or landing wall not exceeding 20, it will have a flow of 38 liters per minute or 137 cubic meter per hour with the pump head of 7 bar. And likewise, these are explained over here. This footnote also covering when the conditions are between 100 and 150, where the further extension of the system beyond 150 hydrant is not anticipated. What does it mean? In the factory areas or industrial areas or in certain building areas, if you want to utilize where the ordinary hazard is applicable according to the requirement, we may have a provision for the future extension by complying with these notes. This is for the high hazard, and generally we are discussing in this training program light hazard and the ordinary hazard. But for the reference, the high hazard is also been explained over here, and it can be followed accordingly. These are the requirement generally to be followed, as we have already explained in the previous slides. Those are the light hazard and the ordinary hazard. Now, for the light hazard, size of mains. This is for hydrant main sizing, and we are covering here the light and ordinary hazard. What is the meaning of hydrant main sizing? As we have already discussed, according to the table 24, and explained those conditions which are required by the NBC, like sizing the riser mains, 150 mm dia and 100 mm dia under those conditions. Further to that, if you happen to have a external hydrant, in that case the internal hydrant mains will remain same as what have been explained in the table 24, but for sizing the external hydrant we have to abide with these tables, which explains that 1 to 20 hydrant, as we had discussed earlier, for the pump's flow and the head, 100 mm will be the riser and the mains diameter, and when you have 25 to 55, it will be 125 and 110. So to my understanding, generally this pipe diameter are not manufactured. So for the practical purpose, for these categories, we can use the 150 mm dia when the number of hydrants are within this requirement. So this makes an easy selection for the main sizes. But the total number of hydrants or the landing walls which shall be counted for the project will include the internal hydrant also. Same thing over here we can apply, as the 125 is a non-standard, we can use the 150 mm dia and overlook this requirement. So I think this explains and simplifies this table for sizing of the mains for the light hazard and the ordinary hazard. For further details and more explanatory notes, you can go through this part of the notes. But most of the notes we have already discussed, like having the residual pressure of the hydrant. Those are given as a 3.5 kg per centimeter square. And at many places we have actually discussed it. And the pressure also required for the light hazard 525, and for the ordinary hazard 7 bar or 5.2 bar, already been discussed and to be followed. This slide explains the hydrant protection system for internal and external for non-industrial buildings. This we had discussed earlier also, and here also the broad guidelines remain the same. That is, a building, the highest floor is more than 22 meters above the surrounding pavement level shall be considered as a high-rise building, although NBC says 15 meters. The rules are applicable to all type of building with non-industrial occupancies, such as residential, hotel, mercantile, business, office, etc. For buildings over 60 meters in height, hydrant system may either be designed as above or may be divided into pressure zones. See, in this regard, there are certain amendments are coming, and when we come to the design of those things, we will discuss for the advanced firefighting system design. And in case of building having a plinth area of exceeding more 750 meter square area, must be provided with the hydrant, external hydrant. And the hydrant's location and the spacing should be installed near the exit. For the light hazard, 60 meter spacing, for ordinary 45, and for the high hazard occupancy is 30 meters. The stand post shall be 80 mm in diameter for single headed hydrants. What does it mean? It means every hydrant or the landing wall has to be supplied by a pipe. In case when there is one outlet or one landing wall, it must have the 80 dia. If there are two landing wall like what we had discussed earlier for the ordinary hazard, it must have 100 dia. And for monitors of 63 and 75 it should be 150 See, what are the monitors? We had discussed earlier also, here also we say, as per the code requirement, the hydrant must be placed within the 15 meter of the periphery of the buildings outlined. If it is exceeding more than that, it must be provided with the monitors. Now, this is explaining notes are there. Double hydrant shall consist of two separate landing walls. A single control wall will not be permitted. It means when there are two walls supplied by the one pipe, it should be separated or isolated by separate walls. So double-headed hydrant will have two control walls and the single